Thanks for coming. This talk is called Infrastructure as Code with Terraform on Azure. I'm Tom. I work on the Azure provider at HashiCorp. And yeah. So just before we get started, who's using Azure out of interest? Nobody. OK. Cool. Is anyone using Terraform or heard of Terraform? OK, cool. And is anyone using any kind of infrastructure as code in general? OK. Mind that. OK. So yeah, I've been at HashiCorp for about 3 years working on the Azure provider. Yeah, we've got quite a presence in Europe now, which is kind of cool. So if you didn't know, HashiCorp have a suite of products. Vagrant Packer, Terraform Vault, Nomad, and Console. They cover the application lifecycle, but this talk is obviously about Terraform, and specifically Terraform and Azure. So just to ensure we're all on the same page, what is infrastructure as code? So infrastructure as code allows you to declaratively define your infrastructure in code, which means that you can apply standard development practices to it. So for example, continuous integration, code review, pull requests, that kind of thing. It also allows you to, like some nice side benefits. So for example, by spinning up your infrastructure in a different region, if your primary region goes down. It has a particular nice benefit in that everything is documented because it's there in code. And it also means that because you're doing pull requests, you can ensure things match the policy they need to. Because it's not just someone going clicking a portal, it's someone actually, like people checking things before they happen. There's some alternatives to this. So in Azure, there's ARM templates. AWS has CloudFormation. Google has Deployment Manager. There's a bunch of them out there. But yeah. So how does infrastructure as code fit in with Terraform? So Terraform itself has a DSL that's known as HCL, which is the HashiCorp configuration language. It's kind of JSON-like. If we just take a quick look, this is some HCL. So in this example, we provision a resource group and a virtual network, and we thread some information through. So in this case, we say create the resource group, then pass the name of that through to the virtual network, so that we create the network inside that resource group. We'll come back to this in a moment. But HCL is nice because it means you have one language which can be used to provision resources across any provider, be that Amazon, like AWS, or Azure, or Google, or VMware, or whatever. But what do I mean by a provider? So today, Terraform supports 120 official providers, so things like, well, yeah, Azure, Google, Hersner Cloud, PagerDuty, like basically everything. And you can write your own as well. So Terraform is just, Terraform provider, just like it's a CRUD API. So as long as you can create, read, and delete something, you can create a Terraform provider for it. But specifically, we support cloud providers, we support DNS providers, we support SaaS services like Bitbucket, whatever. So we actually manage our GitHub with Terraform, which is quite fun. And then there's on-prem as well. So if you've got like a vSphere cluster, you can Terraform that. But yeah, so as I mentioned, we've got 120 official providers. There's then hundreds more of community providers. A cloud popped up, I think it was Hersner Cloud, about a year ago. And the day I saw it announced on Hacker News, I went to Google and I typed in Terraform provider Hersner, and it was literally already there, which was kind of cool. So yeah, so let's go back to a Terraform resource. So this creates a resource group in Azure. If you're unfamiliar with Azure, a resource group contains things and it has a location. So the first thing of note here is the word resource. So Terraform supports two different kinds of resource or thing. There's a data source, which allows you to read information about an existing resource, like read-only. And then there's a resource, which allows you to create or modify that resource. The next thing in here is the resource type. So this is actually 2 bits. It's the name of the provider, the Terraform provider. So in this case, Azure RM or AWS, whatever. And then the name of the thing. So in this case, a resource group. Or for Amazon, this could be like an AWS instance, let's say. There's a bunch of these we'll show you in a bit. Finally, there's an identifier. This is just a friendly name in Terraform. It doesn't actually mean anything to your infrastructure. It's just a way to be able to reference it when you reference between different resources in code. And then finally, there's the fields. So in this case, when I create a resource group, use this name and use this location. Since both of these are required, you need to specify them. If there's optional properties, for example, a resource group supports tags, you don't have to specify them. And if you don't, they'll just be left blank. If you do, then yeah. Cool. So yeah, this is a resource in Terraform. But how do we go from this to actually provisioning a resource group? So Terraform itself is a command line application. You can download the binary from terraform.io, and you just run it on the command line. So if you just run Terraform, what it's going to do is give you a bunch of commands that you can run. Of particular, I'm going to shout out 4 here. So apply, destroy, init, and plan. And we'll just go through each in turn. So the first one that's most important is Terraform init. So Terraform itself it's just the core, essentially. And then we have providers for each different cloud, so AWS or Azure or whatever. And what we do is when you run Terraform init, we look at the code you've written to disk, and we go, hey, you're using AWS, so we need the AWS provider. You're using Azure, so we need that one. And then download them as needed. Terraform plan will then use those providers and say, hey, look at the state of the world locally, look at the state of the world in AWS, Azure, whatever you're using, and then go and diff them and show you the planned changes that it's going to make to your infrastructure. Terraform apply will then go make those changes. So for example, if you've added a new virtual machine, it'll create a virtual machine. And Terraform destroy kind of does what it says on the tin. It just destroys things. Yeah. It can be really handy. So we have some customers who spin up a CI environment at 9 a.m. and then tear it down at 6 p.m. when everyone's gone home. So, yeah. Cool. So let's go through and provision some things. So firstly, I'm assuming that's readable to everybody? Cool. OK. And I'm assuming that's readable as well. Cool. Awesome. OK, so I just have a blank folder here. I have a blank file called main.tf. Cool, zooming works too. So there's 2 things we're going to create here. The first, this is an empty folder with a blank file. The first thing we're going to do is go provider Azure RM. And what this does is say, I want to use the Azure provider. Now, there's a bunch of possible options you can use here, like a subscription. Azure has a subscription, a tenant. AWS has like an account and a VPC you can set, and a bunch of others. But in this case, we're going to say, I want to use this version of the Azure provider, so 136.1. So if we do Terraform init, what that's going to do is say, there's an empty directory here, because there's nothing here, which is great. So next thing to do, we can create a resource. So in this case, we're going to create a resource group. So Azure RM resource _ group. I build stuff, let's say. And the location is your data center, so let's just use West Europe for the sake of it. Okay. So yeah, what this is saying is this will download version 136.1 of the Azure provider. It's kind of important because we release changes frequently as Azure adds new features. So this is just a sanity thing for you. And then we're going to say create this resource group. So if we come through here and we run Terraform apply, wrong folder. That would be why. Terraform init. So if you run Terraform init, first of all, what that's going to do is to say, hey, I need version 136.1 of the Azure provider. I don't have it locally, so it's going to go download that. And we wait. There we go. Cool. So it says it's been successfully initialized, which means it's downloaded the binary, it's there. So the next thing we can do is run Terraform plan. And what that's going to do is look at the state of the world locally. So we have a resource group defined in code, but we haven't got one existing like that in Azure. And so what it's going to say is, hey, I need to create that. So there's one to add here, 0 to change, 0 to destroy. So the next thing we can do is then run Terraform apply. Terraform apply. You'll notice I've not specified any credentials. What it's doing is using the credentials from the Azure CLI, which is kind of nice. And so yeah, so if I run Terraform apply, I get the same plan, and it asks me to approve these changes before it makes them. So what I can do next is type yes. That'll then go provision it. And whilst that's working, if we search in here, I'm going to build stuff. Come on. Where are you? I can see you. Maybe we need to refresh the page. There we go. So yeah, so it's created a resource group in Azure. So at this point, if we rerun Terraform apply, because we've made no changes locally, and because the resource group exists in Azure, nothing should happen, or it should show no changes. And so what we do is reach out to Azure, say, hey, what's the representation of, like, what's the current state of this resource group? Get all the information about it, and then diff it locally. Cool, so there's nothing to add, which is great. So if we come in here and we add some tags, the tags are just like a way of labeling things in Azure, right? So I can do hello equals build stuff, rerun Terraform apply. And what it's going to do is say there's no tags in Azure. There is a tag locally, and so what I need to do is to add that tag. There we go. So this tilde means I'm going to modify this thing, and then the plus is I'm going to add it. There's a minus for remove as well. So yes, if I type yes, that's then going to go make those changes. Come on. Cool. So that's done. And obviously, if we go to Azure, that's now got the tag. So if we add a second one, manual. If we save that, then we run it, that's then going to go, there's two tags in Azure, there's one tag locally, and so what I want to do is remove the second tag in Azure. Yeah, so you see this minus, that means I'm going to delete it. So if I type yes, that'll then be removed. Yeah, man. So if we click off and back on, there's only one tag left. Cool. So yeah, so that's that. There's then the Terraform documentation itself. So all the documentation for Terraform providers is on terraform.io. So if you go to docs, CLI, and then providers, there's a bunch of providers, as I mentioned. Specifically, this talk is about Azure, so let's go with that one. Yeah, and there's all the resources and things that we support down the left. So let's create a virtual network. So in this case, networking resources virtual network. And if we just create a basic network, just take the address space. I get rid of the sidebar, there we go. So what we're going to do is thread some things through. So in this case, we have the resource type here and an identifier, which we're going to thread through here as the resource type and identifier. And we can access fields from one resource in another, so name and location. So let's do build staff network, and then run Terraform apply. So that'll then go add the network. Come on. Cool. So yeah, in this case, add a network with this address space. And there's some fields which are computed, which means that they're changes can be made, like you can make changes in another resource. So for subnets, you can either define them in line here, or you can manage them in a separate resource if you want to. Cool. And then if we come back in here, we should then have a virtual network. Come on. There we go. Okay, so yeah, we have a virtual network with the address space that we defined. So cool. And then we can run Terraform destroy and destroy that as well. Come on. Okay. Now what's quite nice is if you go and delete the virtual network in Azure, we'll detect that that's been deleted and then say, hey, you have it defined locally, it's not defined in Azure, so what I need to do is recreate it. If you run a plan, this is a destroy, so this is just destroying everything. Obviously don't run this in production, or maybe do. But cool. Okay. Come on. I'm just going to leave that destroying. Just trust me, it works. Okay. The other nice thing I didn't mention is that inside the Azure Portal, you have Cloud Shell. And so you can run Terraform straight from the Azure Portal, which is really cool, really handy. So yeah, so just to summarize that. So there's 4 commands you care about, which is Terraform init, which downloads any providers, and gets Terraform ready for use. Also modules, which we'll cover in a minute. Terraform plan, which determines what changes need to be made. Terraform apply, which then goes make those changes. Terraform destroy, which then destroys anything. Yeah. So this is great and all, I hear you saying, but I have all this existing infrastructure kicking around. So how can you work with those? So Terraform supports 2 different approaches for that. There's a data source which allows you to retrieve information about a resource in a read-only fashion. So let's say you're provisioning it by like a central networking team maybe provisions a network, and then you have teams create their own subnets or whatever it is. And this is very similar to a resource we saw earlier. The only difference between them is that rather than saying a resource, you're saying a data. And that says get a data source, so this is read-only rather than editable. So yeah, in this example, what we're doing is to look up a virtual network by its name and the resource group, and then saying, get me the address space for it. Now, you could do anything here. You could say, get me the subnets for that network, and then add a network security group to them, or whatever you're doing. But you can access any field on the data source, which is kind of nice. But it also means that you can create decoupled configurations. So what I talked about earlier, if you have a networking team who manage the network themselves, and then they give you, the development team, like a subnet, that's all supported. So the other thing we support is import. And what this means is I've created this in the portal. I've created it manually, whatever. I want to now start managing this in Terraform. And the way you can do this is by using Terraform's import command. So on the CLI, on the command line, you run Terraform import, the resource name, the identifier, and then the actual resource ID. Now in Azure, these are a bit long, so I apologize, but you can shrink them down in other providers. Slightly easier to read. But if you do this, so in this case, we're importing a resource group. And it's saying, here's the identifier. Go look it up, retrieve the state, match it locally, and it'll mean that Terraform tracks that going forward. And in the documentation on Terraform.io, we have a section at the bottom of each resource saying this is how you import it, to give you like an example. So yeah, let's go through that. So as you can see, that did actually work, which is always nice. whilst we're on the topic, all the examples and everything is in this repo on GitHub. I'll give you the link at the end, but everything is in here. So there's, as I mentioned, there's two different ways of doing this. Where's the code here? So this, that. Cool. So I have a pre-existing virtual network in Azure called Tom Builds Off Network. Where are we? Networks. That one. Keeping me honest here. Yeah, so we have an existing network. That's great. And what we're going to say is, let's assume this was created manually or by a central team or something else. So what we're going to say is, look up the information about the existing network, and then create a subnet within it. So we can do, sorry, we have the right folder. If we run Terraform in it, that's going to download the provider binary again. Come on. It was quicker earlier. I'm just going to do something to speed it up 1 second. There we go. So I've run Terraform init. If I go through and run Terraform apply, I type Terraform a lot. I have an alias, just for TF. So yeah, in this case, so we're going to look up the existing resource and then create a subnet within it. But what's nice is we haven't modified the virtual network at all. We've just created a new thing within it. And you can do this for a bunch of things. Like Terraform supports it. If you want to look up like a blob storage container and then create a blob within it, let's say, you can do that. Or get the credentials for like a Redis account, let's say, and then put that in the app service. You can do that, which is kind of cool. But yeah, so that's gone and created a subnet within this network called my subnet. So that works. Awesome. The other thing you can do, so Terraform supports different providers, and one of those is Kubernetes, which is always popular. Where are we here? So what you can do is to say, I've created a Kubernetes cluster. But let me start downloading. I have a pre-existing Kubernetes cluster here. And so I'm going to say, look up the information about this cluster from this information. And it gives you all this other information that's available, right? So the nodes that are in it and everything else. One of the things that comes out of this is the credentials for it. And so you can thread the information through from the Kubernetes resource to the Kubernetes provider, which means you can then create pods or create namespaces or whatever you want to do. So in this case, we're looking up the information for the Kubernetes cluster. And then separately, we're then going to say, like, use those credentials and then create a namespace within it. So in this case, because we're redoing something from Azure, and creating something in Kubernetes, we're retrieving the Azure provider and the Kubernetes provider. So if we come through and run Terraform apply, all that's going to do is retrieve the credentials from AKS, Azure Kubernetes Service, sorry, and then connect to it and then create a namespace in that. So in this case, it's one to add, which is inside Kubernetes. Whilst that's running, if we get the credentials in another tab, and then we can open the AKS console. Sorry, make that bigger. This is all available in the Azure Portal. It's just quicker to copy and paste it than type it. Ignore that for now. Go to namespaces. Oh, fun. I have RBAC set up and nothing set up. Trust me, that works. Yes, that's created it. It works. It's great. Awesome. And then finally, the other thing you can do is importing. So let's go create a resource group in the portal. I'm using a resource group purely because it's quick, but we could pick anything here. It doesn't really matter. I say it's quick. Come on. Example resource group. So let's just create it in West Europe just because it's vaguely close. Cool. So we created this manually. There we go. That exists. So if we come to our code, I've pre-written this just for convenience. But in this case, I've written the code for this. I guess I should update that. What do I call it? Example resource group. So if I just run Terraform init now, come on. You can cache these once centrally. I'm running a development build, so it was a bit fun, but yeah, what we're going to do is run Terraform plan. And what that's going to do, because Terraform isn't tracking the state of this, Terraform thinks this doesn't exist. Because I've just written this resource locally, but I haven't done anything in Azure. Or Terraform doesn't know I've made that change in Azure. So what I can do is to import this into Terraform, which means that Terraform will track it going forward. And the way you do that is, let's take the resource group as an example. At the bottom of the resource group page, there's this command here. The Terraform import thing, then the ID. So I'm going to copy this one I made earlier. Terraform import Azure, come on. Azure resource group dot example, that, and then the name of it is example resource group. In Azure, the way identifiers work is they just build up one big string. So unfortunately, it's a bit long, but it's different. Like in AWS, they use a short identifier. Cool. And so now what it's saying is that because I've imported that into Terraform, Terraform now knows it exists in Azure, and so it can look it up. So if I run Terraform plan again, what that's going to do is say there's no changes, hopefully. I've done everything right. Awesome. Cool. Okay. And I need to split that. Sorry. Okay. Awesome. So that's great if you have one resource, but what if you have a bunch? So there's a community project called Azure to Terraform, which basically reads the state of a resource group or a subscription or other things in Azure, and will do the import and generate the code for you, which is kind of cool. On the downside, this dumps everything in the root, so you need to move it yourself into modules or whatever as you get on. But it's kind of interesting just to see it, so I recommend taking a look. So yeah, let's talk about modules. So Terraform is, what I've shown you so far is great if you have a few examples, but if you have, let's say you're building 50 things, what do you do? So in Terraform, a module is a directory which contains .tf files. So at the moment, we've just been creating a main.tf, but you can create as many in there as you want. And a module is so what we've created so far is actually a Terraform module. It's just nothing is using it. And a module can have inputs and outputs, although they're both optional. And it can be sourced from different locations. So for example, if I have them on the local file system, I can say from this directory, look in modules example and use that as a module. Or in another Git repo. So we have some customers who have a central infrastructure team who build modules and use SEMVer, semantic versioning. So that they can say, hey, we're going to provide compatibility and ensure that when we publish a new version of the module, you can just use it straight away. The other thing you can do This is based on Git tags, by the way. The other thing you can do is use a module registry. So we have the public module registry. There's also private ones. So if you're developing these in-house, it means people can find modules. There's a bunch on the public one for like if you want to provision console or whatever else. So yeah, so let's deploy some things. So we go to modules. There's 2 in here. So the first one is a VM. Damn it. Thank you. So what I'm going to do, because it's provisioning a VM and this takes a little while, I'm going to kick it off, then walk you through the code. So what it's saying is there's 2 modules it's using. So if I run Terraform apply, let that do its thing, and I'll pull up the code. So what this is going to do is create a resource group, create a network, create a public IP, and then create a virtual machine. And at the end of this is going to use my public SSH key. So I should be able to SSH into this VM and do something. So yeah, let's just go create that and I'll walk you through this. So in this example, we use 2 modules. So we create a resource group at the top level, just for convenience, to be honest, and then thread that information through into the network module, and then subsequently into the virtual machine module. And what we're doing is we're saying create the virtual network with this prefix, this name, and then pass the backend subnet ID out of that module. So this virtual network module creates 3 subnets. Virtual network creates a database, a backend, and a front end. Could create anything. This is just an example. And then what we're going to do is say output the 3 IDs. So in this case, we can use them. And the way you reference this in Azure is say create me this virtual machine in this subnet. And we have some variables to be able to pass them in. So we haven't shown you this yet, but you can have variable definitions in Terraform like so. They can have descriptions, so description, the name of the resource group, or whatever it is. They can have different types, so a string, an integer, an object, whatever. And they can have defaults. So in this case, tags is a map, and if you don't specify any, we want that to be optional. So there's a default there. Okay. That's going and creating it. Awesome. But yeah, as I say, we're threading this through. So we pass the subnet in to the virtual machine module. And yeah, we're going to set up a dynamic private IP, sorry. So say just pick an IP address from the subnet, that's fine. We're going to give it a public IP address. So we can SSH in. And then create a virtual machine running Ubuntu. Details don't particularly matter, but just create a virtual machine and then place my SSH key into it and disable password authentication. What's quite nice is it means you can have teams, you can build modules for, let's say hypothetically you're installing like WordPress or something. You could say this is how we want our modules, this is how we want our machines set up. In terms of like, I don't want them to have SSH access, I want them to have these network rules, whatever, in a module, and then just reuse those. Still creating. Cool. That's done. So we can do SSH user at IP. Do yes. And we have an Ubuntu machine. So we can do all kind of fun things. Or whatever we're doing. Cool. Anyway. But yeah, we have a virtual machine, we can SSH in, we can do what we want. Terraform also supports a thing called provisioners, which says if I'm creating a virtual machine, create the machine, then automatically SSH in and run these scripts. So if you need to make some changes automatically, you can do that. But yeah, that works. The other one I want to show you is app services. So in app services are Azure's version of like Elastic Beanstalk. So it's just saying, give me your code, and like we'll host it for you, we'll do a thing. So another thing we've seen customers do is they have sorry, wrong folder. They have an environment per developer per environment or whatever it is. So in this example, you could have an app service module that's created for your project, and then say, spin me up an example for staging, for CI, and then output your websites. In this case, the app service itself deploys a very, very simple application I've written. My UI skills are not great. And this is just a legacy .NET application, like a .NET 4.7. It doesn't do anything particularly exciting. It just writes a message out the screen. But it shows the concept. So if we run Terraform init, and then apply, just because I don't want to wait for it. You can use Autoprove just to say I don't care about the changes, just make them. Don't do this in production. Cool. So in this case, this is going to create what is you'll need to deploy the website, essentially. So an app service, or it creates a resource group, an app service plan, which hosts app services, and then says, create the app service. And what it's going to do is say, on GitHub, there's a release version of this. Where are we? Releases. So it's going to download the source code from GitHub. Could be from Artifactory or from whatever internal source too. And then deploy that website. Now, this website itself will read a string from the app settings, which is like a configuration file that .NET has. And so we're just going to say hello from production. But what's nice with app service is that each of the slots that gets deployed has its own set of configuration. It has its own domain name. So what we're going to do is provision a app service for each environment, an app service slot. So this is working on it at the moment. It's deployed the app service itself, now deploying the slots. And then when it's done, it's going to output the URIs. Now in this case, the only setting I'm changing between them is the message. You can obviously do more than that. But this is just a simple example. Come on. So we've created one, created the other. An app service in Azure takes a while to boot, so I'm just going to open all of these. The way it works is on the first request, it starts the website, and that takes like 10 seconds just because of the way that works. Come on. Anytime. Maybe I should have used the container. But trust me, it works. What it's going to do is show for each message. It will pop up in a minute. It's going to show for each environment. It's going to show a different message on screen. So hello from production, hello from CI, hello from staging. Come on. It's literally just putting a message on screen. Oh. Give it another minute. Trust me, that works. What we're going to do while it's doing its thing, if we provision another in here, so like build stuff equals hello from Lithuania, and we rerun Terraform apply. Come on. Shouldn't take this long. If we go to the portal, we can see they've provisioned anyway. That'll work. Build stuff resources. Wrong one. I call it build stuff LT. So if we look for the resource group with that name, we can see it's deployed an app service and then 2 environments so far. It's just deploying the 3rd one. Although, apparently, none of them are quite usable just yet. Oh, there we go. There's one. Okay, cool. So we have CI running. We have production, and we have staging. The only difference between these three being the URL, just the way this works, is dash staging, dash CI, or dash nothing. And so build stuff is deploying at the moment. Whenever that's done. One thing you can configure in Azure is to say when this starts, deploy a health check and make sure it's actually running. I haven't done that just for convenience, because it was quicker than this earlier. But okay. What I'm going to say is trust me, that works, because we don't have 5 minutes to kick around. Come on. Sorry about this. Okay, just trust me, that works. Cool. But yeah, the other thing I can show you. But the modules themselves come from the Terraform module registry. So if we can go to registry.terraform.io and say, hey, like here, I want a module for Vault, let's say. And what that's going to do is say, hey, like I want, let's filter by Azure, let's say. Oops, sorry. Filter by Azure. And I have a Vault module for HashiCorp Vault. I have one for Azure Key Vault. I have a bunch of them. And yeah, these are available for all the providers. That's still going. Okay. Anyway. So yeah. So what we've done is to deploy a virtual machine, SSH into it, deployed an app service for multiple environments, and yeah. So when we imported something earlier, we imported it into Terraform State. What is the state file? Well, you may have noticed in the sidebar like a file called Terraform RTF State. And what that is basically a big old JSON file containing everything that we know about these resources that we... Thanks, Siri. Sorry. And it contains all the information about all the resources that we've created or that we're tracking. Yeah. So by default, this is stored locally, but you can also store it remotely. So either we have a service called Terraform Cloud where we'll host that for you, or you can host it yourself in something like, for Azure, like Azure Blob Storage. For Amazon, there's S3. For Google, there's whatever Google has. But it means that you can, you can keep this remotely. The other nice thing is it means if you have two people trying to deploy at the same time, that it'll log. So it'll say when I'm running this deploy, because I'm doing a deploy, you can't do a deploy, or vice versa. So it means you can't have two people accidentally making changes to the environment at the same time, which is really nice. Yeah, so this is using Terraform Cloud, sorry, and then this is using Azure. So in this case, use the storage account, container name, and a key. The key is what you call it. Cool. So what does Terraform support? Short answer is for Azure in particular, like a bunch of things. Everything from compute to VMs, compute to storage to media services to whatever. I've been here 3 years. We've gone from 48 resources to 315 today. Like, there's a lot. We keep adding stuff all the time, as does Microsoft. What's quite nice is that there are some Terraform-specific things. So in this case, if you want to create a storage account and then upload a file to it, you can do that in code. And same for a load balancer. Like in Azure, creating a load balancer is like one big 500-line file. In Terraform, it's a bunch of 10-line resources. So it's a lot easier to read in some cases. Cool. So what about something that's not natively supported? I mentioned we support 315 resources, but what if you want to use something that we haven't got to yet? Well, Terraform supports integration with different functionality. So if you want to use something that's not supported, please open a GitHub issue and we'll get to it. Otherwise, you can use the native integration. So in Azure's case, you can use an ARM template, and they'll say, I want to use Terraform to deploy this ARM template. And you're able to mix and match them. So what it means is that you can deploy resources that aren't supported by Terraform in Terraform, which is kind of cool. Yeah, You can pass variables in both directions. So you want to create a resource group in Terraform, like native Terraform, and then create, I don't know, a blockchain thing. In an ARM template, you can do that, and you can pass the name of the resource group into the ARM template, and then get the blockchain, Bitcoin, I don't know, out of the thing, out of the ARM template, and then use that in something else. Sorry, I'm not up to date with blockchain lingo. The downside is that if you do this, you're basically deploying a JSON file, and so whilst we can diff the JSON file that's been deployed, we can't diff the actual resources. So we can't say, hey, you've scaled this from 3 to 2 instances or whatever you've done, because we don't track that information. But it does, it's like a nice holdover. So you can do this, like there's a resource called Azure ARM template deployment, which deploys an ARM template. And in this case, we generally recommend deploying an ARM template to its own resource group, just for convenience, because it means when we destroy the resource group, we'll clean up everything within it. But you can either define these inline, so here I'm using heredoc syntax with a deploy, or you can read it from an external file. And I'd strongly recommend doing this if you can, because it's a lot more readable, rather than like big JSON inside a HCL resource. Cool. So what about other options? I mentioned earlier Terraform supports provisioner, so you can SSH into a machine and run something. Or for Windows, at least till recently, you could use WinRM to do whatever you're doing on that machine. You can also shell out locally to, say, the Azure CLI or to the AWS CLI or whatever else, and mix and match things as you need to. So for example, you can shell out, to external tooling. But again, like we can't, because we don't track the state of these, we're just running these commands, we can't really diff them or do anything like that. Cool. And you can do that like so. We have a resource called a null resource, but you can also put this within a virtual machine or within anything else. So one thing I just wanted to call out is version 2 of the Azure provider. We put out a blog post, GitHub issue, I guess, at the end of January. This is coming real soon, but it has 4 things I wanted to shout out about. One of them is custom timeouts. So some things in Azure take a while. So at the moment, we have a hard-coded limit internally of 6 hours for certain resources. The next, 2.0 will allow you to override that. So let's take an example with a resource group. You can just add in a timeout block and say, I know this will only ever take 10 minutes to create. If it doesn't, something bad has happened, or I want you to fail. Or vice versa. If you know it's going to take 5 hours, then put 5 hours in there. Next thing is requiring imports. So what this basically means is if you have 2 resources with the same name, at the moment in the 1.x version of the provider, you can just run Terraform apply, and it'll import it into the state by recreating it, because of the way that Azure API actually works. We're fixing this in 2.0, but just a heads up. Yeah, you can opt into this today. The other thing is that we support new virtual machine and virtual machine scale set resources. These are really cool. They're still being worked on, but they're coming real soon. And yeah, they support diffing for everything. And finally, we're removing some deprecated fields. So there's a whole bunch of this. The whole guy is on terraform.io. We're trying to keep this updated over time. But yeah. So just to summarize everything. So Terraform DSL HCL allows for common language to be used to deploy anything on anything. So on AWS, on Azure, on whatever message queue you want. Terraform Plan will show you the changes it's going to make, and the Terraform Apply will make those changes. When you finish, Terraform Destroy will then tear down those resources, and then you can share configuration Terraform modules. So either locally in a mono repo, from different repos, or from a module registry. So as I mentioned, everything is available in that GitHub repo. There's some resources. Yeah, feel free to reach out if you have any questions. But thanks.
I have a question.
Hi.
Is it possible to store state files
In
in Git?
Git, you can. I wouldn't recommend it. Because it's basically a giant JSON file, and it'll diff over time. So if you have everything in a single branch, that's fine. But you would need to do that yourself manually. We don't have a backend for Git specifically. We do have for, right, on the Terraform site itself. CLI. Sorry, we moved things recently. There's a bunch of backends for different cases. HTTP, if you want to store it in like Artifactory or something, we support that. But there isn't one specifically for Git, but you could totally do that. Cool.
Another question.
Sure. Okay. Hey.
I've got a question. Is it possible to iterate through some resources? For example, I want to get all data storage from some resources and apply some change.
Yeah. Yeah, you can do that. You can use the data source to say, find me all the storage accounts with this prefix, let's say, and then say create a container within them or whatever from that. If you want to like manage them going forward, you need to import them into the state and then work with them. But yeah, if you just want to add like a sub resource to them, you can do that. You can also use for each on inner blocks. Cool. So where are we? For like the getting the URL. In fact, sorry, for here, for this creating the slots, we passed in a map essentially, and then said for each one, create it with this key. And then on the way out, we're saying create a map from all the slots that are created. So create a hash essentially of like name to URL. Cool.
It's true that in the state file there is a lot of could be a lot of sensitive data.
Yep.
And how to deal with it? I heard about the pay subscription from Terraform, which can handle this situation. But if you don't want to use this case, how to manage it for production from that environment?
So the question is, how do you encrypt your state file essentially? How do you manage that in production? Short answer, if you're running in a encrypted backend, so if you're running an S3 in blob storage, whatever, it's encrypted there, we recommend limiting permissions at that point and then running Terraform State just in the CI system. As you mentioned, at this point, it's still unencrypted, so it's sat there. But if you're running it and only the CI system has access to it, it's less bad, it's still not great. But we have plans to encrypt that in the future, we've just not got to it yet. So yeah, if you run it as a CI system or you run it in Terraform Cloud, we'll automatically handle that. Cool. I think we're done for time, but take questions.
Is it possible to import a lot of infrastructure without knowing?
No, you need to know the identifier. But so Andy, that's the one. So there's this AZ to TF repo. This will say, where are we? Here. Here's a subscription, import everything. Here's a resource group within a subscription, import everything, or import all availability sets. So you can do it that way, and it will look up the IDs, but yeah. Cool. Well, yeah, if there's any more questions, come grab me afterwards, but thanks.